Okay. To change the order of integration for non-rectangular region, you cannot just simply swap the order and the limit. You have to refer to the sketch R and see how it changes. So it's a different bit compared to the first part. The first part, we are focusing on the constant limit. Okay, so that's why we can just simply change the order. But for non-rectangular region, you have to sketch first. So let's take a look at the example. Evaluate the integral by reversing the order of integration. Okay, if you see the question, they give you type 1, dy dx. So the first thing first is to sketch. Okay, so they give you y equal to x up to y equal to 1, and for x 0 up to 1. Okay, so let's take a look at the sketches. So 0 up to 1 for x, for y equal to x. So this one is dy dx, right, in vertical direction. So in this case, we're going to meet this line first, y equal to x, and then stop here, y equal to 1. Okay, so how to change into the second type, dx dy. So you must remember, if we're going to interchange into dx dy, we're going to change the direction. So in these cases, we're going to change to horizontal direction, and then we fix y. Okay, so we fix y. So y in this case is 0 up to 1, right? And then how to get the limit for x is, this line represents x equal to 0, so that's why we have x equal to 0 here. And then after that, we meet this line. Okay, this line is the end of the region, so y equal to x, so x equal to y. So we make sure in this limit we make x as a constant. So if this line represents y equal to x, so it's equal to x equal to y. So that's why we have y here. Okay, so I did a comparison for original and new. Just a little bit typo here. It should be here is dx dy dx. So this one is correct, only this one. Okay, it should be dx dy here. Some typos here. Okay, I will change it back for my slide. Okay, so after that, after you interchange the order or the limit, you can just simply integrate as usual, whatever methods that you choose. Okay, so the basic idea on interchange the order for non-rectangular region is to sketch first, decide the direction, whether it's vertical or horizontal. Okay, after that you can just integrate. Okay, so let's take a look at this example. So evaluate e to the power of y squared respect to dy dx. In these cases, if you take a look carefully, so we're going to integrate respect to y first. Okay, so it's impossible to integrate. Whatever methods that you choose, method of substitution, by parts, tabular method, or even partial fraction, is not possible to integrate. So the idea to answer this question is basically to interchange the order first, and then later you can integrate. So they give you in type 1 dy dx. Okay, so we're going to change into dx dy. So how can we decide the region? So let's take a look at this one. Okay, here the sketching. Okay, so this is the region basically. Okay, so how can we get dx dy? So in this case, y is fixed. So in this case, y 0 up to 2. So that's why we have 0 to 2. 0 to 2. Okay, and it is in horizontal direction. So you're going to meet this line. This line represents x equal to 0, right? So x equal to 0. So in this case, this line represents y equal to x over 2. Okay, so if we make x as a constant, so we're going to get x equal to 2y. So that's why we have 2y here. Okay, so after we interchange the order, so it will be it will not be easy. It means that you can't integrate. So this one, you integrate respect to x first by making y as a constant, and later you integrate respect to y. Then you will get the answer. Okay, so same goes to this question. The basic idea is to sketch first, to decide the direction, to get the new limits, and then you can integrate after that. Okay, so let's take a look the example the solution that I give in this slide. So if you have any question, you can directly ask me. Thank you.